Do you ever get stuck converting between moles, molecules, and volume? The good news is that there's only two conversion factors needed: Avogadro's number and molar volume at standard temperature and pressure. In this video, I'll show you how to use both of them and also look at a problem that combines them together. So before we set up any problems, we have to remember two key numbers. The first one being that 1 mole equals 6.022 times 10 to the 23rd particles. So if we're talking about an individual element, then it's going to be 6.022 times 10 to the 23rd atoms. If we're talking about molecules, then it's going to be that many molecules inside of a mole. We also want to note that 1 mole of gas at STP, or standard temperature and pressure, is equal to 22.4 liters. So let's look at our first example. If we're asked how many molecules are in 3 moles of H2O, how can we solve this? Well, we want to use Avogadro's number, our very first one, 6.02 times 10 to the 23rd. We're going from moles to molecules. So we're going to start with our 3 moles of H2O and then multiply it by our conversion factor, 6.022 times 10 to the 23rd molecules in 1 mole. I'm putting molecules on the top, moles on the bottom, so that my moles cancel out. One's on the top, one's on the bottom, we cross cancel. Once we do the multiplication, we end up with 1.81 times 10 to the 23rd water molecules. Let's look at another example, this time going from molecules to moles. If we have 4.5 times 10 to the 23rd molecules of CO2, how many moles is this? Well, we're going to start with our term that we have, our 4.5 times 10 to the 24th molecules, and multiply it by the same conversion factor, except now we have to flip it. We need to have our 1 mole on the top and our 6.022 times 10 to the 23rd molecules on the bottom, so that our molecules unit cancels out now. Once we do this math, 4.5 times 10 to the 23rd divided by 6.022 times 10 to the 23rd, we get 7.47 moles of CO2. Now let's do an example with our other conversion factor. How many liters of O2 are in 2.5 moles at STP? Well, we know that our conversion is 22.4 liters are in 1 mole. So 2.5 moles, we're just going to multiply it by our conversion factor. We're going to put 1 mole on the bottom so that it cancels out, 22.4 liters on the top. And when we multiply straight across, we end up with 56 liters of O2. In this example, we're starting with liters, 44.8 liters of N2, and we want to convert it to moles. So here, we're going to use the exact same ratio, except we're going to flip it. So we're going to start with our 44.8 liters of N2 and multiply it by our conversion factor. If you remember, when we started with moles, we put moles on the bottom. Now we're starting with liters, so we're going to put our 22.4 liters on the bottom, and we're going to have our 1 mole at the top. Our liters cancel out. When we do this math, we do 44.8 divided by 22.4, giving us 2 moles of N2. Now let's do a problem where we need to convert between molecules and liters. Now we don't have a direct conversion, so we're going to have to apply both of our conversion factors that we went over in previous examples. So here it asks how many liters of CO2 at STP are in 3.01 times 10 to the 23rd molecules. So the common factor between our two conversion factors that we saw at the beginning are that they both include moles. So if we can get our molecules to moles, then we can convert our moles to liters. So that's exactly what we're going to do. We're going to start with our 3.01 times 10 to the 23rd molecules, and use our Avogadro's number conversion, where 1 mole is equal to 6.022 times 10 to the 23rd particles, or in this case, molecules. Now, once we do this math, we end up with 0.5 moles of our CO2. Now that we're working with moles, we can do our mole to liter conversion to get our answer in liters. So we're going to take our 0.5 moles of CO2 and multiply it by 22.4 liters over 1 mole, giving us a total of 11.2 liters of CO2 from 3.01 times 10 to the 23rd molecules. For more detailed gas and particle problems, you can check out the complete stoichiometry breakdown linked below. And if this helped, subscribe for more chemistry tutorials.